So now we'll barrel into some practice questions for perms and cons, and we're starting with permutations. And as I said, the point of this is to cover some common cases of question types. And you will be exposed to a lot more the more past paper and more exercise questions that you do. So this is just a bit of a cross-section of some of the common ones. So let's have a look at our first problem. Arrangements of gouging, and it says first unrestricted. Now we have 7 letters in total, so that's 7 factorial. However, there are some repeats. The 3s are repeated. And that will give us 840. Now, it says that it wants the vowels to be together. So what we do is when we want things to be together, we treat them as one object. And then arrange it as one with the rest of them. So we've got 5 factorial over 3 factorial because vowels, 3 G's and an N makes 5, and 3 repeated G's. But remember, this we could also do UOI or IOU or something like that. So then we have to, in fact, multiply this by 3 factorial. So that'll give us 120. Now then it needs a consonant at the start and the end. Now here's the first time where we may have to split it into cases, because if it requires a consonant at the start and the end, if we had 2 G's, then you could have OUING, and there's no repeats there. But say you had an N, then you would have 2 G's, and you'd have to account for those repeats. And there's no way to combine that into one equation, so you have to do case 1, starts and ends with G's. So then G, 5 spots in between, and then the other G. Now, because those G's are identical, and they have to be at the start and the end, there's no more than one way to arrange them at the end, so we can just kind of ignore them from the working. And so we've got 5 remaining, no repeats, so that's 120. But then case 2 starts and ends with G and N. 2, 3, 4, 5. N. Now this is like kind of this semi-set, like they're not allowed to be anywhere, but they've been given a few options. So that it could be GN or NG. So that's 2 factorial. And then we multiply it by 5 factorial for the middle, but then we have to divide it by 2 factorial to factor in the repeated G's. So that's 5 factorial, which is 120. Then the total would be 120 plus 120, which is 240. Now the probability that G's are separate and P are that G's are separate would be arrangements with separate G's over total arrangements. So let's have a look at how we can separate the G's. To separate objects, we kind of take them out of consideration temporarily and get the rest. And I've split them up and spaced them out a bit, because now to separate them, all we have to do is to select some of the gaps and arrange some of those gaps. Now, for example, if we're arranging photos and trying to separate some, so we've got 6 photos, and then we're trying to separate 2 specific ones, we'd have a look, okay, there are 5 gaps, and we need to arrange 2 of them. So that would be 5p2. But because g's are identical, we only need to choose the gaps, or arrange them and then divide by the repeats, which is the same as the combinations formula. So it's 4 factorial for this stuff, but then we also must multiply it by 5, choose 2. This is also 5p2 over 2 factorial, by the way. So it's 24 times 5 choose 2, I think it's like 10. Yeah, so that would be 240. And now over total arrangements, and remember, these are our total arrangements, so it'd be which is 2/7. Now the arrangements of 6 people in a line, and 3 of them are girls, 3 of them are boys. And so the arrangements where a couple must stand next to each other. And it's the same thing as making sure the vowels are together. We kind of treat them as one object. But remember, they're 2 different people, so you would have to factor in the 2 factorial there. Then 6 minus 2 is 4, got 4 remaining people. And so altogether 5 items. So do 5 factorial times 2 factorial, which is 240. And where Brendan must stand at the front. So imagine you've got a line of 6 people. Brendan must be here. He can't be anywhere else, so we essentially just ignore him. And just do 5 factorial, which is 120. Now 2 enemies must be separated by at least 2 other people, so it's a certain separation. So by at least 2 other people. So let's remove the enemies for the time being and leave some gaps between the remaining 4 people. Now let's do all the cases where they can be separated by at least 2 people. They can either be like this, that's 2 people apart, or like this, where they're 2 people apart, or like this, where they're 2 people apart. And they could have been switched around anyway, so that's again, I'd probably split it into cases. You would do the 4 factorial multiplied by, there's one way here, another way here, and then another way here. So that's 3 times 2. And so that's 24 times 6, which is 144, I think. And then case 2, they are 3 people apart. You can either go like this, or like this. So that's 4 factorial times 2 times 2, which is 96, I think. And then case 3, they're 4 people apart. And that's there's only one way to arrange those guests, times 2, so that would be 48, then you add them together. And the probability that the 3 girls are standing together. And so essentially we're treating it as one item, and then you got boys. So that becomes 4 factorial multiplied by 3 factorial. This is arrangement of whole group and arrangement of girls. And then so the P of 3 girls together is just going to be 4 factorial times 3 factorial over 6 factorial, because 6 factorial is the total way you can do it. And that's 1/5. Now on to a personal favourite question of mine. We've got some cans of drink, 3 identical cans of cola, 2 of green tea, and 2 of orange juice arranged in a row. And find the arrangements where the first and last cans are the same type of drink. And let's put it into cases, because remember we've got the problem of having 3 cola cans. So if it was cola at the start and the end, or not, then we may or may not have to factor in different divisions to get rid of repeats. So we'll do cases. Case 1, cola at start and end. So it looks something like this. We know that there will be colas at the start and the end. They're identical, so we don't really need to worry about them. And in here, it'll be 5 factorial over 2 factorial times 2 factorial, because there are 2 green teas and 2 orange juices which are identical. So that is 30. In case 2 would be OJ at start and end. And remember, you've got Coke, 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 green tea, green tea. And so that'll end up being 5 factorial over 3 factorial times 2 factorial. So that's 10. And then if we do case 3, green teas at start and end, you may have recognised that you actually don't need to do a separate case for this, because it will be the same calculation as the orange juices being at the start and the end, but I mean it's just good to be thorough. And then you would add them together. And now the arrangements of 3 cans of Coke being next to each other and separating the 2 cans of green teas. So I think we should start by ignoring momentarily the green teas and focus on the Cokes and the OJs. So remember, we can just treat those Cokes as one object, then those orange juices are separate. Now, usually we'd have to factor in arrangements of stuff within that little group, but because they're identical, we don't have to worry about that. But still, when we arrange these 3 things as a group, we have to account for those orange juices being identical. So we divide by 2 factorial, and that gives us 3. But there's another condition, so we're going to have to multiply it by something, and that's when the 2 green teas are separated. And essentially the green teas, as you know, can go in the gaps. There are 4 gaps to choose from, and we need 2 of them because there are 2 cans of green tea, and we don't need to arrange them because the green teas are identical. So 4 choose 2 is 6, 3 times 6 equals 18. And a reminder, if you factored this in for the arrangements within the group, it would just be 3 factorial over 3 factorial, because there are 3 objects, but there are also 3 repeats of an object. So if you wanted to be pedantic, then there's that. And also this is equivalent to 4p2 divided by 2 factorial. So that's 18 is the answer. So now on to this question about roses. Now, these 7 roses, even though some of them are the same colour, they're not going to all be identical. So with that having been said, let's barrel into the questions. White roses are all separate. So as we know, when we want to separate things, we ignore them for the time being, arrange the rest. So we've got 1, 2, 3, 4, 5 remaining. That's 5 factorial. Then we put them in gaps. So we multiply that by 6p2. Because we've got 6 slots and we want to choose 2 of them and then arrange the whites in them. So that gives us 3,600. Now for blue and yellow to go on the ends. Now notice this says on the ends and not blue must be at the start, yellow must be at the end. So basically there are 2 ways you could do it, because you could do blue at the start, yellow at end, or yellow at start and blue at end. And now we'll just multiply that by 5 factorial, because remember these flowers aren't identical, so that gives us 240. Now the probability, when we do pins and cons probability, the probability is equal to the number of favourable arrangements with the condition, divided by the total number of arrangements. So, I mean, just think about it. We got 5. Now, at the start and the end, we could have red or blue. And we've got 4 options, because there are 3 red roses and 1 blue rose. So we just do 4p2 to arrange the start and end, and then we just multiply by 5 factorial to deal with the rest in the middle. So that gives us 1,440. And so then we do 1,440 divided by 7 factorial, and that gives us 2/7. So now onto this question. Part A has a combinations question, so we'll just skip to B and C, which are permutations questions. So find the number of seating arrangements for the 8 friends. So you got 8 friends, and Rajid and Sue must sit at table X. So we don't need to choose between X and Y. We know they can be at X, and we know they can be on the same side. So there could be 2 sides that they pick, because there are 2 sides of the table. And then on that side, Rajid could sit on Sue's left, or Rajid could sit on Sue's right. So we'll do 2 times 2 to account for that. And then, you would just do 6 factorial to arrange the other 6 people, because Tan decides he does not mind which table he sits. So it'll just be 6 factorial. And that will equal 4 times 7, 20, which is 28, 80? Yeah, I think so. And then, so that's B. Now C. Right, 8 friends stand in a line for a photograph. Rajid and Sue stand next to each other, but neither of them are at the end of the line. So what I would do is I would take Rajid and Sue out, then I'd arrange 6 people, the other 6 people, then put them in later. And then I'll just put this in R and S. Now you could do 2 factorial ways of arranging them, 6 factorial ways of arranging them, and then Rajid and Sue could go in here, 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 or here. So that's 2 factorial times 6 factorial times 5, which is 7,200. So those are the permutations questions that I've prepared, and in the next video we'll be doing combinations questions.